Hello guys, welcome to GeeklyEDU. My name is Eddie and today we will be talking about Finite Series. So as we know, a series is basically a summation of the terms in a sequence. And it can look something like this, where this counter tells me where n will start, and this tells me where it will end, and this tells me the sequence of numbers that we will be adding. Fantastic. Now, an example of a finite series could be summation from n equals 1 to 5 of n, which is very simple. 1 plus 2 plus 3 plus 4 plus 5. Now, whenever we're doing a problem that pertains finite series, now we want to find literally the sum of a certain quantity of numbers, okay? Something that we could do in a calculator. However, instead of having this problem right here, which we could even do in our heads, what happens if I put a 0 here? Well, okay, it's 48 numbers, not that hard. I can still plug it in the calculator, it's just gonna take a little bit longer. Now what happens if I add another 0? Now I have 498 numbers. It's not necessarily hard, but it's gonna be very time consuming. So what we want is to try to find a way to identify what the n summation will be for some finite series without actually having to sum all the numbers, just because that will take way too long. So I'll give you a couple examples to show what could be done just to make our lives a little bit easier. The first one is going to be arithmetic series. And basically, arithmetic series will look like this. Okay, let's say that it goes from 1 to 60. So, if I wanted to do this in a calculator, we'd have to get 2 plus 3 plus 2 plus 6 plus 2 plus 9 plus till we get to 2 plus 180. That's going to take way too long. So, what we're going to do is we're going to use this fantastic equation, which tells you that the summation will be equal to n over 2 times a1 plus an, where this tells you the number of elements in the summation. This tells you the first term, and this tells you the last term. So we're literally just going to plug in those numbers there. But how do we know that we can use this equation? Basically, whenever we have a series where the n is not raised to a power, or we don't have a number raised to the power of n, we can use this, okay? So arithmetic series, nothing raised to the power of n. So, very simple. Now we just plug in the numbers. We know that the first term is 5. We know that the last term is 182. So, S of n will be equal to, how many terms do we have? Again, very easy. We have 60 terms. Now, how do we know there's 60? Well, let's do a little trial here. Let's imagine that I want to go from 1 to 4. So I have 1 plus 2 plus 3 plus 4. So whenever I start at 1, this is the number of elements. If I started at 2, then that would change a little bit. But in this case, I have 60 terms. I divide that by 2, and then I have 5 plus 182. And this will be equal to 5,610. So, as a recap, whenever you have a series and you don't have n as an exponent, nothing is raised to the power of n minus 1, n plus 1, we're dealing with an arithmetic series. So what we do is we're going to use this formula. Okay, where n tells you how many elements, how many terms you have in your series. A1 is the first term, an is the last term. Now, what happens if n is an exponent in the series? Well, let's do a second example to exemplify that. Here we're going to have geometric series. And these geometric series, because they're finite, they're slightly different from the infinite geometric series. Now let's imagine that for a problem, we were given this. 4 plus 12 plus 36 plus 108 plus plus 2,916. And we need to try to find the sigma notation. So first thing we need to do is we need to try to find a relationship, a pattern between the terms. And right away, we can tell that 4 times 3 is 12. 12 times 3 is 36. Times 3, 108. And then we need to do times 3 many times. So we start with our sigma notation here on the left. We're going to start at 1. And we know that the first term, because I'm going to have a 3 here, that's going to be multiplying every single time, but not the first term. So 3 is going to be to the power of n minus 1 times 4. And then I just check if this makes sense, okay? Because the first term would be 4 times 3 to the power of 0 plus 4 times 3 to the power of 1 plus blah, blah, blah. This one is 4, this one is 12, and if we keep checking, we get 36, 108, etc. Now, there is still something we're missing, though. When does this series end? Well, very simple. This number here, n, will give us our final term. So, this means that 4 times 3 to the power of uppercase n minus 1, the last number, is going to be equal to the last term. And now we need to solve this equation. Here we're going to get 3n minus 1 is equal to 729. We need to use logarithms, and eventually we find that n is equal to 7. So then our series is going to be from n equals 1 to 7 of 4 times 3 to the n minus 1. But now, remember, we're adding numbers up, so we want to know what the end number is. Very simple. For geometric series, the formula we're going to use is S of n equals a1 plus 1 minus r to the power of n divided 1 minus r, where this is the first term. Again, this is the number of terms in the series, and r is the number being raised to the power of n minus 1. So we just plug in those numbers. Sn is going to be equal to 4 times 1 minus 3 to the power of n, which in this case is 7, divided by 1 minus 3. Okay, and then at this point, we can plug it in the calculator, do whatever, and we will get that the summation is equal to 4,372. So, it is very important when we're talking about finite series to understand whether they are a geometric series or an arithmetic series. If they're geometric, meaning there is a number that is being raised to the power of n, n minus 1, n plus 1, this is the equation we will be using. If there are no terms being raised to the power of n, this is the equation we will use. And after that, it's just plug and chug. So I hope you guys understood everything. And if you didn't, please leave a comment in the video. We will try to get back to you as soon as possible. Don't forget to like and subscribe. We're posting videos almost every day. We're here for you. And yeah, have a great day.